What's up guys, this is Massey. Welcome to another video. In this video I want to show you how to calculate the pH after 0.02 mole of HCl is added to the liter of the mixture of containing 0.1 molar of acid and 0.1 molar of NaC3H5O2. So first of all, HC3H5O2 is propanoic acid, and NaC3H5O2 is sodium propanoate, which is the conjugate base of this acid. Basically, the mixture of these two is going to be the buffer solution. So let's find out what is the pH of this buffer solution before addition of this acid. We already calculated in the other example. I'm gonna just show you again. We had this acid plus water is gonna give me hydronium ion plus the conjugate base. In the initial concentration is 0.1 molar. So we have it says 0.1 molar of acid, 0.1 molar of the conjugate. So we have 0.1, 0 and 0.1. Change is going to be negative x, x and x for the product. So at equilibrium we have 0.1 minus x, and here we have x, and the conjugate base is going to be 0.1 plus x. So then I can say Ka, which is 1.3 times 10 to the power of negative 5 for this acid, equals to x times 0.1 plus x divided by 0.1 minus x. So then when you neglect x comparing to 0.1, I can cancel these two x's, and after that 0.1 and 0.1 cancel out, I can say x equals to 1.3 times 10 to the power of negative 5. So pH is going to be negative log 1.3 times 10 to the power of negative 5. So pH is 4.89. So before addition of this acid, the pH is 4.89 for this buffer solution. Now let's see if we add this 0.02 mole of acid, what is going to happen. So I can say here C3H5O2 minus plus proton. Why proton? HCl is a strong acid, so it dissociates completely in aqueous solution to H plus and Cl minus. So the concentration is going to be exactly the same thing because we have complete dissociation. So when they react, it's going to produce an acid. So HC3H5O2. So the initial number of moles of this conjugate was 0.1. Here we have 0.02 moles, and for acid we have 0.1 because that's the buffer solution with 0.1 from each. Then acid and base, they react. This one is greater than this one, so it's going to neutralize this one. So we have 0.1 minus 0.02, 0.02 minus 0.02, 0.1 plus 0.02. It's going to add because in the product side. So 0.1 minus 0.02 is going to be 0.08. Here we have 0. Here we have 0.12. So now the concentration is going to change. So I'm going to write the equilibrium condition again. So ice table, initially we have 0.12 of the acid. This one is gonna be 0, and here we have 0.08. This is not actually 0, it is 10 to the power of negative 7, which we approximately make it equal to 0. Change negative x plus x plus x. So we have 0.12 minus x, x, and 0.08 plus x. Then I can say Ka, which is 1.3 times 10 to the power of negative 5 equals to x times 0.08 plus x divided by 0.12 minus x. So x and x cancel out because we assume that they are much lower than 0.08 and 0.12. So x will be 0.12 times 1.3 times 10 to the power of negative 5 divided by 0.08. So that's gonna make it 1.5. It's gonna be 1.95 times 10 to the power of negative 5. So pH will be negative log 1.95 times 10 to the power of negative 5. It is gonna give me pH will be 4.71. So now, as you see here, when we add this acid, the pH is gonna change from 4.89 to 4.71. It is not much. Why? Because we are dealing with a buffer solution. So when we have a buffer solution, if we add acid or base, buffer solution is gonna resist to pH change. So that's why pH didn't change much. I hope you enjoyed this video. Please leave me a comment if you have any question. Thank you for watching and have a great day.